All right, so we are going to continue on with describing non-numeric data. So we spent a lot of time talking about kind of the options we have when we're working with numeric data and the kinds of measures that we can create and the kinds of, a little bit about some of the graphs that we can make. So we're just going to do a brief word about some of the options we have when we're working with non-numeric data. And I'll be honest up front, we're not going to do a lot of work with categorical data in this class, but we are going to talk about just a couple things here. So here's an example of some categorical data that I collected from a previous semester class. I asked students, let's see, where is the question? Oh, how they got to class that morning. So when we were meeting in person in in-person class, how did you get to class that morning? So the 5 options that students had were mostly bus, mostly car, mostly bike, walked whole way, or other. And these are the different responses that I got. So basically what we're doing here is we're just making a frequency table. It's not a very pretty frequency table, but it is a functional frequency table where we can just look at the data on R, and then we can just see how many responses we got for each category. Now, unlike numeric data, this is actually very summarized and helpful as it is, right? So like the raw data in this case is, doesn't need a whole lot of extra summary because I can very quickly see what's going on in this variable. Now, there are a couple measures that we should be familiar with, and the one we're just going to talk about briefly here is a proportion. We'll talk about this a lot more in a later chapter, but a proportion is just going to be the percentage of responses that fall into one particular category. So in this case, we could find the proportion of students who said that they walked the entire way to class, and that's just going to be the number of people who said that response divided by the total. So if 187 people took the survey and 112 people selected that response, then 112 out of 187 will equal our proportion, which comes out to 0.599, we could also turn that into a percentage. 59.9% would be the proportion of students who said that they walked to class in our sample. Again, we want to be careful here that there still is a distinction between statistics and parameters. A statistic is a measure of a sample. A parameter is a measure of a population that we're probably not going to know. So let's say that if my population were UIUC students, then I don't know the proportion of UIUC students who walked to their first class, but I do know the proportion of my sample who walked to their first class. And if I have reason to believe that my sample is representative of the UIUC student body, I don't know if that's actually a good assumption or not. I have questions about that based on, well, they're all walking to one particular classroom. Is this classroom centrally located or not? So I think we could kind of nitpick and critique that assumption that it's probably not a representative sample. But for sake of example, let's just say it was. Then I would assume that the true parameter is probably relatively close to this sample proportion, that I'm probably off by a couple percentage points. I could calculate something called the margin of error and find out how much error I should expect here. But the short story is there exists a parameter. I don't know what it is, but hopefully my sample proportion is a reasonable estimate of that parameter. Can we measure variability in categorical data? I mentioned this just because we will do that when we're working with a binary variable, meaning that we only have 2 responses, or we kind of take our categorical data and just lump it into 2 responses. Like we could say walked away versus didn't, right? Like we could do that in this case if we wanted to. And when I have binary data, I can calculate a standard deviation in that case. I could just convert my categories to a 0 and a 1. I can input 0s and 1s into my standard deviation formula, and I could calculate average distance from 0.599 among my 0s and 1s. So it gives me a little bit sense of how much variability there is in responses, right? So like, my standard deviation is going to be high if I have about the same number of responses for each category. My standard deviation will be low if it's very one-sided. But again, we'll talk about that more in a later chapter, but I could calculate a standard deviation for binary data. If I'm trying to calculate some measure of variability for 3 or more categories, that gets a lot trickier, and it's something that we won't tackle in this class. But there does exist categorical data analysis courses. If you are a stats major, you will very likely take categorical data analysis as part of the major, and you'll learn a lot more about some different options and kind of perspectives to understanding categorical data. Graphically describing categorical data is not super complicated, or at least we're not going to make it super complicated. Usually we're just going to use something like a bar plot to look at our variable. We could also make stacked bar plots if you wanted to look at 2 categorical variables at the same time. But typically a bar plot is a really helpful way of just seeing how many responses we have in each category. Assuming they're non-ordered categories, obviously ordering doesn't matter. But if we have like a discrete variable, maybe we have some ordering that we want to preserve, then we just want to make sure that we input the data in such a way that we're going to get the ordering correct in R. All right, so we will stop there.